And for this third session, we have Professor Dr. Praful Kumar Panda sir with us for this session. Dr. Praful Kumar Panda, presently working as a Dean, School of Engineering and Technology, Century University of Technology and Management, Odisha. He also worked as an associate professor and head of the department in civil engineering and coordinator of data science and machine learning research center at Century University of Technology and Management. Sir has proven this in creating patents on identification of hydrocarbon locales of an unexplored basin using space inputs and GIS. Second patent, disease control and combat mapping for tribal fortification using geospatial approach, IoT for agricultural practices, food waste recycling machine using IoT, wastewater treatment device, IoT-based vermicomposting. His area of interest in surveying, remote sensing, and GIS, applied geology, water resource engineering, disaster mitigation and management. He has more than 50 international and national journal and conference papers to his credit. Professor Panda has life member in different professional bodies, reviewer and editor of various journals. He has completed 2 projects from Government of India, EST, NRDMS, Department of Science and Technology, and Natural Resources Data Management System. He has received various awards for creative invention in research excellence and academic award 2018 from CSER. Sir has also received research excellence award in 2019 from INSC and Bharat Vikas award in 2019 from ISR. Sir has awarded with 9th Science and Technology Award from EET. Sir has awarded by ISRI India and making many plays in social media in 2023. He is also awarded by ISRI India Transferring Geospatial Technology 2023. He is the National Nodal Coordinator for ISRO IIRS EduSat program, and Sir has also certified trainer from ISRI India. And the most important introduction is that we have organized this international conference, and many of the speakers, experts, as given by Praful Kumar Panda sir. So we are very thankful, sir, to you. And on behalf of our Phaltan Education Society's College of Engineering, Phaltan, I heartily welcome you for this international conference and request you for your session. Thank you, sir.
Yeah, thank you, Doctor. So, very good afternoon to all of you. I think my voice is audible.
Yes,
okay.
Sir. Yes, sir.
So I think you are doing in a hybrid mode. Am I right? Is it hybrid mode, yeah, or only that you are online, you are doing? I think it is a hybrid mode, right?
Yes.
Any other persons are doing or joining through online?
Yes, sir. Yes, sir.
Yeah. Okay. So thank you once again for my brief introduction, and particularly thank you organizers so inviting me as a resource person for this particularly your international workshop. So I can share my screen here. So my screen is visible.
Yes, sir. Screen is visible.
Slides are visible. Is my slide is visible?
Yes, sir. Yes.
Okay. Yeah. Yeah, I'm going to talk about in this international conference that is your geospatial technology for sustainable development. So as organizers, they have already introduced me. So presently I am working as a Dean in School of Engineering and Technology. Along with that, I'm heading the Department of the Civil Engineering as well as the coordinator of Data Science and the Machine Learning Research Center at the Centurion University of Technology and Management. So whenever we are coming for these recent tools and the techniques, particularly with respect to have certain sustainable development goals, because whenever we are going for any type of the topic, that means with reference to the present conference, so I have decided, okay, let me go through this geospatial technology for sustainable development. So these are my structure of the talk. So before going to my primary the topics, so I'll talk about the National Geospatial Policy, that means why it has been developed and who will be benefit for that, then how it will have some important roles or the vital roles to the society as well as to the nation or to the particular institute levels. I will talk about the overview of the space technology, Indian space programs, then space technology applications with respect to sustainable development goals, role of the remote sensing, role of the geomatics, and final thing, I will talk about the geospatial technology for the developmental activities. So these are my structure of the talk throughout that 1 hour. So particularly whenever you will have any questions or any query, after the talk we can discuss, or meanwhile you can intervene and we can discuss there. Yeah, whenever we are talking about this National Geospatial Policy, the Minister of the Science and the Technology has notified the National Geospatial Policy, that means what we're calling NGP, in the 2022. So with the goal of the making India a world leader in the the geospatial sector. And the same thing which has been adopted, our Prime Minister Modi has that certain aims, that means towards the digitalization aspects, make India, skill India. So all these important factors which is coming under that also. India's geospatial economy is expected to cross 63,000 crore by the 2025 at a growth rate of 12.8%, and to provide the employment to more than 10 lakh people, obviously. So whenever you will have your economic or your perspective, everything it will be developed or it will be increased, the employment will be increased in that particular, it's vice versa. In 2021, the Minister of the Science and Technology issued the guidelines for the acquiring and the producing geospatial data and the geospatial data servicing, including the maps. While the guidelines deregulated the geospatial sector by leveraging the geospatial data acquisition, production, access, the 2022 policy takes it the further by laying down the overarching the framework of holistic development in that particular area. So once you will develop the map or once you will have the data acquisition, it should be open for the public. It should not be hindered in a certain level. Everybody can access the data. Everybody can produce. If X has produced some map, n number of people can access that map. But presently these things are not happening, where we can have something that hidden policy or something like that. But now we are coming across that. We are going for some holistic approach and providing the data sets to the public. Then what is this National Geospatial Policy which has been developed in the 2022? It is a citizen-centric policy based on geospatial technology which seeks to strengthen the geospatial sector to support the national development, its economic prosperity, and thrive in the information economy. The policy is aimed to set up the high-resolution topographical survey and mapping with the high-accuracy digital elevation model by 2020 or 2030. So whenever we are talking about all these aspects, we are talking about the topographical survey. In the topographical survey, we can develop all these minute details. And let me tell you one thing, the presently what we are doing for the state of Uttar Pradesh, land parcel demarcation of the land, that whatever the land they have, the farmer land, we are going for the center digitalized. So with the help of GIS, with the help of the drone technology, and meanwhile, what it has been mentioned in that policy, we can get the high accuracy digital elevation model because we are getting the. Am I audible? Am I audible? Because in that online something.
Yes, sir. Yes, sir.
Yeah. In that the Cartosat data, what we are getting from our own resources with respect to the ISRO or the Bhuvan sites, so which is having 5-meter resolution or the 2.5-meter resolution. But now we are going for which data will be freely available. This entire world's digital elevation model will be available by the 2030. And keeping its view and goals, it aims to make India the world leader in the global geospatial space with the best in the class ecosystem for the innovation. Obviously, that our innovations never stopped. We are leading with respect to the perspective of the world we are going towards. To develop the coherent national framework in the country and leverage it to the move towards the digital economy and improve the service to the citizen. Obviously, whatever the work you need to do, it need to come across or it need to serve the people or towards the society. To develop the geospatial infrastructure, but certainly you need have the geospatial skill of the knowledge, some specific standards, and finally it should have the geospatial business because that is India, Pan India. Those are the people, those who are coming towards the institution level, coming towards the nation level, giving the sophisticated softwares to produce or to keep the data, to create the various type of the maps which can be used for the further, that is your n number of times. To promote the innovation, strengthen the national and the subnational arrangements for the generation and the management of the geospatial information. But as the institute, we should have some certain frameworks. A geospatial data promotion or the development committee at the national level shall be the apex body for the formulating and the implementing strategy related to promotion of the geospatial sector. Every institute, it should have the geospatial policy, that committee. That means whatever the data you will have, that data it will be collected and it will be shared. GDPDC would replace the subname in the functions and the power of the National Spatial Data Committee, NSDC, which has been constituted in the 2006, and GDPDC the constituted in the 2021. The Department of the Science and Technology shall continue to be the nodal department of the government, and the GDPDC shall make the suitable recommendation to the Department of Science and Technology in the discharge of its the function related to the geospatial region. In a particular area, if the work is, or some work is happening, or that related to the work, it should go to that in the national level, or it should go to that world level. As a milestone towards the realization of the policy of the vision, in the year 2025, put in the place and enabling the policy and the legal framework that supports the liberalization of the geospatial sector, democratization of the data for the enhanced commercial or the value-added services, So that value-added services is an individual impacts it should have. And in the year 2030, high resolution topographical survey mapping, so which will come, that 5 to 10 centimeter for the urban area, 50 centimeter to 100 centimeter forest or the wasteland. Very, very fine resolution, the data sets which will be available. So one of the mission which is working, particularly our ISRO is working with the NASA to come across or to provide the such type of the solution. Year 2035, high resolution accuracy bathymetric geospatial data of inland waters, because we are only talking about the surface of that air surface, but whenever we are not talking about whatever the things are happening below the water level, if the silt will be present, then how to remove that such type of the silt and all other things. In that case, we are going for the drone technology, or we are going for this bathymetric or the sonar. But using the satellite data sheets or the data sets, we can go for that subsurface, the topography of the shallow, deep seas to support the blue economy, which will be developed. The National Digital Twin, yes, we have started, particularly the Centurion University of Technology Management, we have started from the 2017, the concept of the digital twin. That means as it is, looks, we have developed this Amaravati, that means in the Vijayawada, or near to Vijayawada, wherever the state of, that the capital of Andhra Pradesh. So we have provided, and the typically example, for the state of the Odisha, we have developed our own digital twin city. The digital twin is the virtual replace of the physical assets, the process or the service that lies at the core of the new digital revolution. National Digital Twin would be an ecosystem for the smart, dynamic and connected digital twins. Obviously, in the smart cities, whenever we are talking about, we should not forget about the principles of the GPR, that is your ground penetrating radar, because everywhere we are going for the smartness to identify the leakages, to identify the some type of, that is your cable collapse. All the things in the superficial you cannot do. We can go for that within that 15 meter depth or within the 10 meter depth, what are things are happening, we need to find it out. Because we need to develop or we need to use sophisticated instruments, sophisticated technology, because technology has been developed in a recent, that is your national scale worldwide. We need to adapt. And the same thing is happening whenever this globalization, and particularly this is the era of AI, artificial intelligence, and the same thing is happening there. So geospatial technology and data can be agents of the transformation achieving the sustainable development goals. This is the vibrant initiative to promote the startup and reduce the last mile dependency on the foreign soils. We can develop that the slogan which is given by our the Prime Minister Modi ji, Make India concept, Skill India concept, and we can promote ourselves through the different startups. Geospatial data play a vital role in a wide spectrum of the frequency of the critical data management applications, such as the military operations, disaster and emergency management, environmental monitoring, land and the city planning. Everything, if you go for in a consequence manner, or you can go for a holistic approach, you can go with the different type of mapping proposals. So that maps the data, you can store it, you can develop it, then you can go for usage proposals after that. So now I will talk about a few things regarding about this Indian space programs. So which has been, because you can able to see our Dr. Vikram Sarabhai ji. So let Dr. Vikram Sarabhai ji with that is your which has been initiated in the 1960, the Indian Space Organization in the 1962, INCOSPAR, Then in the 1969, Indian Space Research Organization, 1972, the Space Commission Department and the Science, and with the planning, the development of the different satellites. So INSAT Coordination Committee, so the proposed was the satellite communication programs only. Planning Committee on the National Resource Management System, all the remote sensing programs which has been developed. Advisory Committee for the Space Science, and that is the Space Science program, that means the 3 wings which has been developed there. But in the years, 177 plus missions which has been developed in the various applications of the various types and the different payloads which has been developed. And all of you know that we have already launched our the satellites to the Mars or to the Moon, and we have seen that Mangalyaan as well as the Chandrayaan. 105 satellites with respect to remote sensing, communication, navigation purposes of the space science, what we are getting, and some of the few satellites that developed by our own students throughout the India, that means the different institutions. 5 experimental missions, space capsule recovery experiments, crew module atmospheric re-enter experiments, reusable launch vehicle technology demonstrator, scavenge engine technology demonstrator, and the crew escape system on the launch. That means nearly 297 satellites of the 33 countries which have been done. But as far as the India is concerned, we have the 2 launch pads in the Sriharikota, which has been developed in the 2005, and depending upon the satellite launching vehicle, advanced satellite launching vehicle, or polar satellite launching vehicle, geostationary satellite launching vehicle, like that the Mach 3, the different stages, the rockets which has been, or the payloads which has been developed, and the various space programs, through the space programs, the satellites which has been launched to the space. In the India, the space program in a 4-dimensional perspective. So the vision is the harness the space technology for the national development, while pursuing the space science, research, and the planetary exploration. So we'll have the space transportation. In the space transportation, we'll have PSLV, GSLV, just now I have discussed there. And we'll have the space infrastructure. In the space infrastructure, we can go for the Earth observation, communication, navigation, space science, and the planetary missions which have been developed. But in the space applications, we can go for the socio-economic security, sustainable development, disaster response, and the governance, we can get it. And meanwhile, we can come for this capacity building. In the capacity building, we can go for this human resource development, innovation, technical infrastructure, international cooperation, industry and academia, and the outreach. So this is one of the most, the burning thing in every institute you can find towards the capacity building. Obviously, if the same mentality people, they can sit together, they can develop. And frankly speaking, many of the institutes and many of the faculty, they don't have the trust among themselves to come forward towards the collaboration, to come forward the cooperation. Actually, with respect to that, I remembered one thing. So whenever I'm addressing to any gathering, Modi ji have told, I'm not coming for any political background, but this is your own experience, what I'm telling you. Sabke saath, sabke vishwas, and the final thing, sabka prayas. So until unless we cannot do the prayas, you cannot be success. So whether it is industry or whether it is academia, so both industry and academia, whenever will they meet with each other, and they come with some of the certain, they can identify some of the problems, and that problems it will come in the form of that is a new solution. So what exactly in the new era what we are looking for? So this in the capacity building. So these are the various India's current space assets with respect to the 17 communication satellites and the more than 300 transportation and different the bands which has been used, and the remote sensing satellites which has been used, and Gaganayan you may have heard, and recently that is your Chandrayaan 3, and the Mangalayan we have seen, and Aditya L1 also. So these are the recent development what I'm talking about the satellite or with respect to the space program in India. And we have the navigation in the India constellations with respect to the satellite constellations. So we can get the IRNS 1A, 1I, and 1C, 1D, or 1G. And all these things, so depending upon is the standard and the restricted the position in services, and we can get the accuracy near about the 5 meter, and the time accuracy you can get it the nearly about the numbers. And these are the fleet management with respect to this aviation and the maritime service, geofencing or something like that, and the earth atmosphere studies of various the applications what we can call. Then in this space we are talking about eyes in the sky with respect to if you see from the sky we can go for this on application. I can tell that is your land and water. So in the land or water, we can go for this resource 2, resource 2A. If you come across that is your high resolution satellites, Cartosat 2 series, Cartosat 1, the different the series which are there. If you come across this ocean, that means your ocean color monitoring applications or for ocean studies. All weather and the climate types, because nowadays you can find in the space program every 24 hours whatever the changes are occurring on the surface of the earth, something because some flood is or somewhere the earthquake is occurring, very quickly you are getting this data, and the data which is accessible and which is in that internet, very quickly you can find it out. And same thing is happening in the case of your flood. Flood is occurred yesterday, and today we can get it that how much it has been affected, then how it has been spread. That means you can getting all these multi-temporal aspects, the change dynamic behavior, we are getting it. And meanwhile also, the imaging capability, that means the resolution portions, it has been developed 1 kilometer to that is your 0.65 meter. Very that fine resolution. Even if it is ant on the surface of the earth, you can also detect, because in that the particular region it can be detected by the sensor actually. We are using, because in the remote sensing of the space technology, we are using this is the technology that is your push broom technology or the push broom technology. If you are moving with some of the drums, that is your whisk broom, that is your broom you will have. If you are going along that track or you are going across the track. And most important thing that is we are going for this 3-tier imaging, where we are getting the resolutions with respect to low resolution, high resolution, or it is in a broader sense also. It can manage or it can detect that is your snow, or if you have the different the flight planning or some of the things you can also it can be detected. Very typical things in your Cartosat 2S image, where all these buildings, that is your 0.65 centimeter, all these information you can very high accuracy, because I am talking about the Indian the satellite point of view. But if you go for this quick bar, once again 65, even if that is your 0.45, that is a centimeter which will be available, very that means fine resolutions which will available there. And even though you can count the cars from this, it is not the drone, it is only the satellite. I think it's visible for all of you. You can count the cars also. the bridge is there, footbridge. Yeah. Now coming to this space technology and how it has been teamed with this sustainable development goals. If we talk about this socio-economic, the security, we should not forget about this food, water and energy. It will come under this health sector. It will provide the shelter. It will have the infrastructure. It will have some of the information. Disaster risk reduction, preparedness, early warning, response and recovery. Any type of disaster, because the most typical things, all the disasters are occurring only in that holidays, because that is my experience, what I have seen in the 2008 Kosi flood. So that was also in that particular time, a holiday. So the breach was occurred. And recently we have heard the Joshimath, because these are the burning things right now. Joshimath is subsiding. I think all of you are getting my point, what I'm talking. You know, online. So sometimes what is happening is, in the other hand, all will sleep. I think all of you are getting my point. Or
Yes, sir.
is it?
Yes.
All of you are getting my point?
Yes, sir.
Yeah. No, because some of the topics I don't know. Whenever I am coming for this space technology or maybe in the geospatial technology, sometimes it will be bounce back. It will not coming to that background also. Anyway. Yeah. So in that disaster point of view, that Joshimath, that land subsidence, last year I was in that issue Dehradun. Whenever we are discussing in a panel, why that land is subsiding. So we are having a concept, when the group of people, they will meet each other, they will talk in a different perspective or it is in their own perspective. Geologist will tell something. Management people, they will talk something. Remote sensing people, they will talk something. Hydrologist will tell something. So like that, because there will be no coordination. So if any disaster is happening in a particular area, so who is the person who will go first? Now just, we can go for some interaction actually. I am not asking the question. It is the understanding actually. If any type of disaster is occurring, who will go first to that particular? So I am not getting anything from that audience. Sir, can you? If disaster is occurring, is happening, who is the person who will come first? I think my voice is clear. If anything is happening, any type of disaster or any other thing, who is the person who will come first? Because large audience is there, I thought that someone will tell. The first person is the local people. The local people, if any accident or anything is happening, that local people is come. So whenever we have discussed with respect to that Joshimath, that is a land subsidence, the various people in the different area, they are talking with each other. But the NDRF team, the rapid force, the rapid action people, those who are going, that means we can develop the technology, we can develop a number of things, maps or so many things. but if it is not used by the people, the local people, they cannot see. We are producing a map and we are telling that this is a tectonic map. This area is coming under the severe earthquake prone zone. But if the local people will be sensitized, they should be aware. In that case, everything will happen. Then there is no requirement of the sustainable goal also. Every people will be aware themselves. Actually, that is the main concept whenever I am talking about. We need to aware everyone. Everybody should know that what is happening. And that is the community engagement. Any type of research if you are doing, if that research is not coming towards the community development or the community benefit, that research does not have value anything. So the young generations, they are doing something, they are developing the prototype, but it should come. Yeah. So let me go through once again this sustainable development impact. It's the climate and the change aspects, urbanization, because you can able to see everything is happening. Then we can go for this governance aspect, we can go for the planning, we can go for monitoring, we can go for evaluating, and finally we will come across with respect to the decision support. Then when we are talking about all aspects, one aspect is, because whenever we are talking about the geomatics, there is the two sides of the coin. One is the remote sensing, another is the GIS. So this remote sensing concept, sensing of an object without having any physical touch. So that is what we are calling the remote sensing. So this role of the remote sensing useful for generating the environment indicators that can be integrated with the whole lateral data and the social indicators, so which is available. And it is providing the synaptic view, like the bird's eye view, what exact pinpoint area. And it is having the multi-resolution, multispectral. Most the important thing that is your repetitive offers, the repetitive coverage, unbiased mapping, monitoring of the natural resources, both in the space as well as the time domain. Timely and accurately information with the respect to the spatial distribution, land use, soil, vegetation density, whether it is a forest coverage or whether it is a geology, water resource, whatever it may be. And this remote sensing data in the conjunction with the collateral data helps in the delineation of the ridge line. So particularly whenever we can go for the different applications, mineral exploration, water, that is the groundwater tables or the groundwater recharge areas. So that in that case we can go for the different type of activities. It's characterization, it's the prioritization, or we can go for any type of erosional activities that we can do it. So this is the general concepts, which is starting from, we require actually three things. We require the source of energy, we require a sensor, and we require that is the target area. And along with that, we require some of the data transmission, data recording, and it will have the storage device, and finally we will come for that is your analysis purposes. So this electromagnetic radiation from the source to the target, the 2 times it is interacting with the atmosphere actually. And the sensor which will be available, that means what we are calling a super sensor, which will be available, which will be gather this information or will collect this information through reflection, transmission, or it is some of the radiation principle or refraction principle, whatever it may be. The main concept is to find out this technologies, what I have already told there. And in this electromagnetic radiation, we will have this both two waves, magnetic as well as the electric wave, which is traveling perpendicular to each other and with the speed of the light, which is we are getting both this straw and it's the crest, and whenever this total amount of energy is coming, we are calling this is the photon. Actually, the principle of the remote sensing, the physical principles in the physics, what we have already studied in our intermediate the level. And the same thing is happening. These electromagnetic waves can be transmitting as it is have the both electric field as well as the magnetic field. In the 3D diagram, you can able to see it is reaching its at the same time it's reaching its the maxima as well as it is reaching to its the minima. And the same thing is what I am showing here. That is the polarized propagating wave from left to right, both electric field and the magnetic field in a phase difference as well as you can able to see it's reaching its the minima as well as the maxima axis. This is the wavelength region, what we are talking about. Visible region, infrared region, or after that we will have thermal region, microwave region, like that. The different wavelength regions are there. And depending upon the sensors, then it has been designed in such a way that the certain portions of the light, it is working. Not only that, some portions, whenever this emitted, that whenever that amount of energy, it will be come from the source, some portions it will be affected or it will be not affect, actually it will be transmitted, it will be targeted, then some portion of the light it will be absorbed, some portion of the light it will be transmitted, and some portion of light it will be reflect back. But not only always we will go for this reflection, but in some of the times there we will get the least absorption, actually what we are calling these atmospheric windows. These are the imaging capability of India with respect to air, with respect to low orbiting, or with respect to geo-earth orbiting the satellite, and what depending upon these altitudes. You will have if you are using this helicopter laser terrain map or some of the LiDAR sensors you can use. Some of the high resolution imaging in the LEO you are getting, and geo you are getting some of the hotspots. These are the Earth observing satellites in the various time frame. These are the various missions starting from 2016 to 19, and it's carry on towards to 2025. And what you can able to see, whenever the resolution with respect to the spatial resolution which has been increased, and finally we are getting the final resolution and we are getting the final product, that means the satellite image what we are getting very the fine resolution data sets. Then whatever the different type of applications what we are getting, we'll have the remote sensing platforms. We can go for the pre-processing. Some of the softwares we can use. We can remove some of the errors, then which can be used for the different application point of view. Then we can produce the maps. That maps it will come in the form of the tables, or maybe sometimes we can get some of the reports. And the most important thing, we can get the different layers. That is the n number of layers we can find, and we can go for different applications and to find out the solutions. If it is agriculture, if it is water resource, or if it is land use and urban planning, or wetland mapping, or so many things. In the remotes, particularly in that India, what are the users and which are the applications? Central Ministry, that is your departments like your agriculture, environmental forest, rural development, urban development, water resource, ocean development, mines, and starting from the state government and the NGO, as well as the academic, as well as the university also. These are the various applications with respect to forest, bioresource, water resource, geology, and finally the natural resource information, land water resource development, and you can go for some of the strategic applications too. If you come for these agricultural applications, the crop acreage and the production estimate, we can estimate or you can go for the predict depending upon the yield. Remote sensing based crop yield model, different models you can generate. Crop condition assessment, agricultural drought assessment, crop conditions in the different time frames. If there is some diseases, that diseases and whatever the pest you need to apply and where need to apply, all this information you can find it out. Soil resources, soil mapping at the different scales, generation of the land capability and the land irritability of the maps, that means which will be once again helpful for the farmers. Soil moisture estimations using some of the microwave data, land degradation, mapping and the monitoring of the waterlogged areas in that particular area, or if it is somewhat the salt affected soils, or if it is eroded lands and it is going for the shifting of the cultivations. If you come for this land use land cover, you will go for the change detection analysis. District wise, waste land mapping you can go for. In a particular area, due to the rapid growth of the urbanization, then what is the significant changes, what we are calling the urban sprawl studies in a urban area. Growth center analysis from that particular area, how much growth and what are the indicators. In the forest, we can go for the forest cover mapping, monitoring, forest fire, risk mapping, grassland, environmental impact and assessment or the analysis what we can do. If you come for this water resource, we will go for this surface water mapping, flood damage assessment, flood risk zoning mapping, identification of the flood embankment signs, runoff for the forecasting, reservoir sedimentation and the drainage congestion studies, what we can find it out. In the every aspects and the every departments of the every verticals or every domains, it is having the significant applications in that particular area. If you go for the ocean application, potential fishing zones you can find it. Monitoring and the navigation of the channels. We will go for the coastal zone mapping and the coral reef, and you can come for the some of the biosphere. And finally, we are also using that integrated mission for the sustainable development, the sustainable watershed development, the approaches which is coming also. Then another aspect, that is your role of the geomatics. Once again, it is a integrated approach. Remote sensing, GIS, GPS and DGPS, everything will play a role. In this integration of the natural resource information in conjunction of the socio-economic data, generation of the local specific action plans for the land and waters, we can go for this generation of the variety of the derived maps or assessment of the existing infrastructure to arrive a development the scheme. Why will we go for this? We will go for this, apply the principle of the remote sensing and GIS to create the map and the retrieval of the spatial information, plan, assess and evaluate the natural, man-made and the system in the geospatial models. And if somebody wants to develop the research activity or the capabilities to handle the multidisciplinary field projects, then how it will be the work in that condition? Art, science, engineering and technology which will be associated with the answering the geophysical questions. Always a geologist, for example, I am giving the pattern of the earthquake, where it is happened, how it is happened, then in which area or where it has been spread. Hydrologist, a pattern of the pollutant spreads. Climatologist, the change in that ozone hole. Politician, because our election is coming, obviously the politicians, they are anxiously they are voting for that. in a particular constituency, what about that voting and how much they are getting. Forester, the spread of the forest fire, we have seen there so many things, the applications, particularly with respect to GIS. You know, whenever you are talking about this GIS, what is that? Geographical or the geospatial information. So what it will be provide? The knowledge about what is, where and when. Because always we should not forget about the time. And with respect to this GIS, the 3S, the concepts what we are getting, the system, the science, and the studies. System in the sense, whatever the technology we are using or we are adapting. Science, the concepts and its theory, how it can be implemented. Studies, whenever you are going to implement that study in the field, that means we are coming from lab to field, that is your societal, the context. As per the definition is concerned, a system of integrated computer-based tools for end-to-end processing, capturing, storing, retrieving, analysis of the display of the data using location on the earth surface for interrelation in the support of operation, management, decision, and sciences. So that is in a nutshell what we are talking about, the geographical information system, which will provide you all these things. You can see here the data which you are getting from the field, satellite data, aerial photographs, analog maps, data which will be stored, data will be manipulated, different type of classifications will do, data analysis will also we can do, different models you can run, and finally it will come in the form of, that is your images, graphs, maps, or any of the tables. So what are the functions of the GIS? This is the what is. Once again it will ask the location base, where it is, that is a conditional thing. What has changed? What spatial pattern exists? And most important thing, you can create the three-dimensional perspective thing if you go or you will ask the query that models what if scenario. It's a very thing that means we will come for this virtual thing. We can see that what is the modern India. Then how this, the concept of digitalization, skill India, make India, and it's the growth rate, how it will be developed, how it will come across, then how the employment will be increased, what are the factors, then what are the triggering factors which will be helped towards the development of any of the nations. All the things you can able to see. Various softwares what we are using, particularly ArcGIS, Idris, NB, TNT, Margin, or some of the open source softwares like the Saga, QGIS, Google Earth Engine, or something like that. What exactly we can able to see from the virtual entity to object, the virtual things, what it can be the produce in a map. Now the next thing is what is required with respect to your sustainable development activities in the national level, institutional level, agricultures, the National Crop Forest Center, which is available, water, India water resource information, forest, state forests, ocean, national level, geospatial data usage, rural development, urban development, land resource, and with respect to the disaster management, and which is coming under with one theme with respect to in the state, that is your Indian. Temporal monitoring the land use pattern, what you can see, that is whatever the land cover which is there, then how much land which has been changed, then how the wasteland it has been changed in that all the aspects. If we will go for the crop production estimation, before harvesting, what should be there, then whatever the type of the crops, whether it is Kharif, Rabi or the summer type, then how taking that the food grain availability, then whatever the policies are there, how much stocks you should have, then in the pre-harvest production, that estimations, whether it is rice, wheat or mustard, sugarcane, cotton, whatever it may be. If your data set will be available, then you can go for that, the prediction proposals. In the India, what is 12 major information system having 108 spatial layers with 5 to 100 years hydrometeorological data, which is available. So where you can get the best data, whenever we are talking about once, if you go to this India Wari site, lots of data is available. That data you need to utilize for your different interested. If you go for the water quality, you will get it. Turbidity, pH data, TDS, everything you can find. If you go for this basin transfer, so particularly the few years ago we are talking about this interlinking of the rivers. That is Godavari river to that Krishna river. And you can see in that Tamil Nadu, that is the Kaveri river to that Periyar river or something like that, which has been already, few things has been done. In that surface water dynamic, we can see the continuous monitoring of all these water bodies. It's a very, very interesting thing. If you are seeing or if you are monitoring through the satellite, I'm not talking about drone till now, because drone is now. Drone age or the drone things, what we are adopting also. We are taking, I will show you in my last 2 slides. I will not take more time, probably 1 hour already gone. Very quickly, I need to complete it because I have, once again, I'm in the meeting, I need to go. Then in the National Drinking Water Mission, groundwater exploration. So if you go for this Bhuvan side, you can get all this information from that point of view. Hydrological information, groundwater exploration, the barriers of the groundwater movements like dolomites or the dikes, groundwater prospects, or you can go for this sustainability map. Then you can come for this forest type of the biodiversity. So where you can get all this information, watershed or the soil water conservations in the different areas, wherever the site locations will have available, and best is integrated water management, particularly in that Chhattisgarh and some parts of Maharashtra, some parts of Odisha also, that very, that means the watershed management program is working very effectively. Rural access monitoring, Mahatma Gandhi mission. So where you can find the web portals or the mobile app. In this Manrega spatial environmental, you find spatial environmental, you can find assessment supervisor. So everything is linked with that. You can develop it or you can get this data. In that Amrit scheme, urban geospatial data is being prepared using very high resolution satellite data for the shuttle mission of the rejuvenation and urban transformation. The database also generated will be in for the urban master the plan preparation, because all this data, and this is your part of the Thrissur in the Kerala area, all the data, it will be in the compact thing, that means you can use the data sets. Pradhan Mantri Awas Yojana, housing for all, because once again it is a slogan for every people. So where you can find how many it has been started and how many in the foundation or how many in that lintel or how many it is having the roof and it is completed. See, you can see it in that one and you can get all this information through the satellites and through the portal also, that means in the applications. Disaster management support in the different area. For example, I am giving, if it is a floods, fire, forest fire, cyclone, landslide, or it is a drought, or it is a earthquake, something like that. Then it will come for the cyclone prediction. Whatever the track is having its intensity, where it will be landfall, then how much storm surge it will become, then and how we are going for providing this all this warning and the communications. So that information we can get it. In the Kerala and Karnataka disaster in the 2008, so depending upon the different areas, how the landslide occur or the flood inundation map is there, then landslide identification going to the field and from the satellite, where is the toe, where is the crown, all this information we can find it from this remote sensing or the space-based data sets. Kerala floods, how we responded from the space data, that means, another thing, whenever we are talking about the state Odisha, that means my own state, already famous for any type of disaster management. Effectively they are doing. Cyclone, flood, they are doing, or any type of the disaster is coming. Now that is your naval position of the missions for the fishermen. Where is the locations? Where is the fishing zones? All these informations, or if anything is alerts also it will come. If it is high waves or the high tides or if cyclone or tsunami, every information it can be shared to that. That app which is available for this the fishermen. And if you go to the Bhuvan Geo portal, you can get all this information. You can get the data sets in the National Geospatial Engine. Actually, according to that policy, you can get all this information. The 1 meter to 2.5 meter satellite data for the nation, which is available, digital surface model from the Cartosat, or giving that 3D models with the stereo pairs, you can get it, multi-temporal or the multi-sensor data coverage, what you can get it, or 100 millions of, that is your geotags at the point of interest. And another thing, this image or this slide I have taken from this ISRO, with respect to this hyperspectral, whenever we are talking about this multispectral, within the certain range it is working. For these advanced versions, within this 0.4 to 0.5, 10 or 12 bands will be there, narrow bands, which will provide once again the nano informations. And the same thing, that is the future of the, once again, the remote sensing. That means what we are calling the ultra remote sensing, ultra edge remote sensing. Instead of 100, it will have the thousands of bands. The hyperspectral, then ultra edge remote sensing. But as the Centurion University of Technology Management, so whatever the different aspects, the project, because wherever I'm going, I'm showing these two slides actually, for whether it is the research, for the student, for collaboration, for any other thing. Different machine learning projects, what we're doing, that car detection, parking, or project in that agriculture with respect to digit detection. Multispectral and hyperspectral, using that mineral identification. Healthcare with respect to cancer. Elephant projects, what we have. Corridor. As a geospatial survey or providing the solutions with respect to certain SDG goals, we are using drone. We are developing volumetric analysis. We are going for the geospatial, that is your geophysical survey. Soil health monitoring, that is your digital soil health. You are also preparing. Mineral mapping, identification of the different type of minerals. Hyperspectral mapping. And finally, we are coming very, very important thing, that is your LIDAR remote sensing also, LIDAR sensing what we are doing. So with amalgaming all the things, few achievements also we got, and we are having the collaborator like ISRI is our partner, CBRI is our partner, IIRS also is our partner. So with that, we are going towards and spreading the geospatial technology for sustainable development. Actually, this is my last slide. Yeah. And thank you. So this is the, with respect to that lunar mission. I have taken that size. I am keeping here. If you have any discussion, once again, I am ready to discuss here.
Anyone has a doubt? Please ask the question. Look at outline. Thank you, sir. On behalf of College of Engineering, Phaltan, I would like to thank Dr. Prafulla Kumar Panda, as he has given a wonderful session on geospatial technology for sustainable development. What we have understood is that there are a lot of applications of geosensing technology. The technology is basically used for the disaster management, like a flood management. Also, it is used to help for the weather forecasting and all other applications, and it is mostly helpful to the fishermen into the sea for the navigation purpose. Also, it is helpful to the navigation of naval officers. So there are a lot more applications provided by geospatial technology. And once again, I am very much thankful on behalf of College of Engineering, Phaltan, to Dr. Prasanna Kumar Panda for his wonderful session. Thank you, sir.
Yeah, thank you. Namaste.
Namaste.